So this is a quick video on how to set out a house, or in this case an extension, but you would use the same principle in either case. So you can see here that we've got some string which goes around on top of the foundations. Now this string here is the second stage of setting out, and it's done quite is there to show you where the walls are going to go, because we're laying blocks at the moment. First of all, this was done for digging the trenches. So what you would do, you find out where the centre of your trench is. Now in this case I need to fit a 300mm wall in here like that, and that will run out from the house and form the extension on two sides, which is a fairly simple concept, I suppose. But you have to start thinking a bit ahead of where you're going to go in terms of the build, because if we were to line this string up with the existing edge of the house, then we haven't left room for our render after we've finished. So as you can see, I've chiseled a little bit of render off here to find how thick the render is, which in this case is quite thick, probably over an inch or 24mm, and so that's where we've lined up the string in this case. So that forms our first reference point. And then you can see here I've measured 150mm in to find where the centre of the wall is, and that is where the centre line for digging your trench is, because you want your footings to be centred around the centre of your wall, because theoretically your wall should sit right in the centre of the footing. So that's what that little mark is there for. That's half the width of the wall in from the existing blockwork. Okay, now if you were building a house from scratch, you wouldn't need to worry about the existing blockwork. You just have to make sure that your trenches are square, and by that I mean, if you were looking down on a plan of the house, all the corners should be right angles, kind of like this. Because if they're not, then that will cause all sorts of problems with materials and roofing and all sorts of things. Helicopter, can we see it? Oh, no, missed it. Okay, so back to the strings. So first of all, we measure our width across to the other side. You can see over the other side we have another profile board there, and these profile boards are set to be at the level of the DPC. Now this, as you can see, I've got marked on the wall here the finished floor level of the inside of the house. Now what we did there, we transferred a level out using an optical level. Now I don't know if you've seen one of these. You have a big stripy stick. I'll go and find it so you can see what I mean. There it is, big stripy stick, and on there are the measurements. You can hire these from any sort of tool hire place, and they're a very handy, quick way of transferring levels. You need two people, and to do it simply, all you do is you would take that in the house, and you look through the level. It's a bit like a telescope, and I wonder if we can actually look through it. Let's have a go. Where's the hole on the camera? Is that going to work? Oh, you can just about see the cross there, can't you? So you put that cross there on the I get that to focus? Yeah, so you can see the cross there. You put the cross on the stripy stick, you read off the number off the stripy stick, and then what you want to do is get someone to bring it out here. They hold the staff up against the wall, they move it up and down so you get the same number again, and then you mark off where your finished floor level is. Now obviously your finished floor level might include tiles or floorboards, so you want to allow for that. Come down a bit more, and that's where your floor level, timber level, floor timber level in this case, or screed level would be in when you're building your extension. So that's the levels. Now that level there is the level I've set all these profile boards at, which is the top of the unfinished floor, if you like. So if you look all the way around, all these profile boards are set at the same level. So and the reason you have a board is like this across the top is it allows for uncertainty. You can screw a piece of board up, you put a level across the top to check its level, and then you can finally adjust from left to right your strings, which is important for the next bit, which is squaring the whole thing up. So how we square things up is you measure the distance from here to there where your other wall is going. Okay, so that's your one distance, and then you measure down this length here. Okay, so you carry the string on to the profile board. Okay, so you've got two measurements. You've got the measurement of the width here, like that, and then you've got the measurement down here, right the way down to your profile board. This is to find the first right angle in this corner here. So it's to find the right angle between A and B in this drawing. Okay, and to do that you use Pythagoras' theorem. Now that sounds complicated, but there's an online calculator for it, and you just put in the two sides, side A and side B, okay, down to the profile board, and the calculator will spit out the diagonal. It works it out for you. So which of the diagonal will be from the point over there where the line is, diagonally across the site to the where you've got your profile board. Tape measure, you put the tape measure along here, not the string, sorry, and you mark out your measurement. Okay, if you want, you can hold a pen on the on the correct measurement point on the tape measure and scribe a line, a bit like you would if it was a very large pair of compasses or something. And then you would do the same, take your tape measure again and measure out that diagonal. Now where those 2 points match up, the two measurements coincide, that is will make a right angle in this. So as you can see, the green lines in this drawing are your string going out to the red profile boards. This corner, bit confusing. I might insert a image at this point to show you what I mean. As you can see, we're building this building on a slope, so the profile boards at this end have to be quite high to reflect the unfinished floor level at this end of the site, but ordinarily they'd probably be a similar height to these ones, just poking up above the ground level. When you're putting these profile boards up, it's well worth doing it well away from where you're going to dig any trenches or anything like that, because obviously if you're using a digger you need sufficient space to fit that in. So yeah, that's important. So once you've got your profile boards up and you've got a straight, you've got a right angle here, and you've run a line out here to there, you can do the same on the other side. So the diagonal will go from here to there, and the other edge would be this one here, and then you have your measurement of the width at the back here, and hopefully you will end up with a right angle there. And you can check to whether your maths has been correct by checking whether these two lines are parallel, and they should be parallel with one another. So the red arrows in this drawing show where you should measure to check for parallels. Both measurements should be the same. Two lines coming out if you've got it right. So once you've got your two parallel lines coming away from the house, the next step is to set up the gable wall in this instance, which you can see running along here in this yellow string. And how we did that, rightly or wrongly, is you take a tape measure and you simply measure out very carefully, without touching this string here, along the length of the house, and then you set up these profile boards either end. We've got one screwed onto a building here, or some goalposts over there, and you just move the string backwards and forwards till it's in exactly the right spot. So we're talking about the black arrows in this drawing. And it's important to make some adjustments here for where the wall is going relative to the trench. So it's quite common after you've dug a trench to find out that it's not quite straight, because when you're operating a digger, and the ground might be a bit uneven or something, the trench might end up slightly crooked. So as you can see in this instance, the trench is either a bit narrow at this point here, or it's been bent round somehow, and so we had to adjust the wall. You can see there's 2 marks on this line here. This is where the wall's meant to go according to the plans which we submitted for planning, but we've had to move it in a bit because the trench wasn't straight. And we had to check both ends to make sure we had enough room to fit the wall. So because our wall is 300 millimeters thick, so we should just about have space, well, plenty of space actually, to run our wall up through these footings. So that's roughly how you set out an extension. You can use, when these lines have been put in place, before you dig your foundations, you can use a long spirit level, which I'll show you over here, or a plumb line to here's the long spirit level. So you might, without touching the string, you just place it up against the string, the spirit level, so it comes down like this, and then where it hits the ground you can mark it out with some marker paint, or a trowel full of lime, or even cement powder I use this time round, and then you just run a line along where you're going to dig your trench, and then you can take these lines down. You mark where the strings go on the profiles once you've got it all carefully set out, and then after you've dug your trenches, you can put the strings back up to mark out where the walls are going to go on top of the concrete. So it's probably easier to do than to explain, to be honest, but this is what it all looks like. As you can see, it worked because the walls are going in the trench okay. They're in the middle of the trench, and so everything should be fine. So this was quite a satisfying point in the project, because you realise that all the work you've done up to this point will actually work, and your house isn't going to be crooked. An important reason to get it all square, the building, it doesn't really matter. You could still get building regulations approval with a wonky house, provided it's wonky in terms of its right angles. It's not important. But as you move up, everything, if the house isn't square, everything will be more difficult, because the floorboards you put down, when you put them in the corners, they won't fit properly. They'll have to be cut. The insulation, if you're using rigid insulation, that will all have to be cut in the corners because they're not right angles. So you might have 4 or 5 layers of rigid insulation, which you'll have to cut because it's not right angle all the way up through the house as it goes up, and your roof tiles won't fit on properly. The roofing felt won't run down nicely along the side of the house because it's not right angled. So that's why it's important to get it right angled. All the building materials all work on right angles. So if the base isn't right angles, then you're just making tons of work for yourself on the way up. So worth doing, I think, and probably why people bother to do it in the first place. So this is the old school way of setting out a house without using any fancy survey gear. If you haven't got a dumpy level to transfer the levels from outside, you could actually just use a long piece of wood or a long level I've got here with a spirit level on top, and you could just transfer the level out. So you put one end of your long stick in the house on the finished floor level, and then you you extend out to a point where you can mark it, perhaps the wall, and then you mark on the wall the level, move the level along a bit, mark it again on the far end from where your last reference point was, and that way you can work a level around the outside of the house to the point where you need it. Of course, it's probably more accurate and a bit quicker to use an optical level, but if you don't know how to use one, or you haven't got one, or you can't be bothered to hire one or learn how to use one, then you can always just use a spirit level. So there you go, that's enough prattling on. Got any questions, please leave them in the comments section. I'll do my best to answer them. I'll post a narrated set of images to explain what I mean by the Pythagoras' theorem bit, but this is a system which works in the real world, doesn't require any fancy equipment, and can be done with 2 people in about 6 hours if you're know roughly what you're doing. And that is about it. Quick note on the profile boards, these ones are quite tall. Okay, if you're building on a slope like this and you need a tall profile board, then really you want to brace it, because the last thing you want to do is do all your measurements all super duper carefully, okay, and then when you tighten up these strings, the profile board flexes, and then all of a sudden you've lost all that hard work you put in, all that accuracy is lost because this is just bending around all over the place. So that's why these are built like the proverbial poop house, and I would probably recommend a bit of bracing. We've used some rather unorthodox bits of freshly cut timber here for the bracing, which is what was available, and but it's okay for the job. So that's that. Okay, thanks for watching, and yeah, I'll report back soon with some more bits and bobs.